All right, so please give a big warm welcome to our second speaker this evening, talking about Distribu-ready with the Modular Monolith, Layla Porter.
I usually get the round of applause at the end, but I'll take it at the beginning as well. So thank you, Dylan. Yes, my name is Layla. Can you hear me at the back? I shall try and project. If I lose my voice, I will get a microphone delivered, but we'll see. So we're going to talk about Distribu-ready with the Modular Monolith, and it flows on quite nicely from Andrew's talk. So I think there'll be some things that are familiar. I do have some weird generated AI. Who doesn't? It is weird and I love it and it's fantastic. But I do have to warn you, you might get a little bit of a scare. So I want to start with this quote from Sir Richard Branson. Complexity is your enemy. Any fool can make something complicated. It is hard to keep things simple. And I think Andrew explained that quite well. What I want you to think about as I go through all of these is everything we talk about and everything we add is going to add complexity to your systems. Everything you hear about at conferences, you watch on YouTube, everything you do that you add to your systems is going to add complexity. And that's something that you need to think about. And it is so easy just to go and get a new Git package, install it, and run it. It is much harder to think about it programmatically and think, actually, could I just implement this pattern myself rather than going for the latest buzzword, new Git package, bringing it in and all its stuff that it brings in with it, and then all of its dependencies and all of that. And it's much easier sometimes to take some thought and go that little bit further and do something that is actually simple, but is harder on you because you have to think about it and you have to do it rather than getting an off-the-shelf solution. So just think about that as one aspect, and also just everything I'm about to tell you, it's going to add complexity, okay? So we hear a lot of talk about these two things, these two solutions. We have our monolith and we have our distributed systems. And I do love the representation with Stonehenge because like our staffs and stones, they do look very much like a microservice and all their little connection, because they all are coupled by something. So we do have that kind of thing. So just in case you're not sure, let's just recap. So a monolithic architecture is that traditional approach that you're probably very familiar with, that you've always done or you learnt with. The thing is, it's a single executable, sometimes a few others, but let's just say it's a single executable. Everything is in the one code base. It's simple to develop. It's simple to debug. You can get it loaded onto your machine. A new starter can pick it up. It's easy. Conversely, microservices, we're breaking everything up into individual applications. They're microservices, but they are applications, executables in their own right. You are going to find that more difficult. If you've got hundreds of them, which so many of these systems, well, sometimes there's even thousands of them. You as the developer, what are you going to do with that? How are you going to get that running on your local machine? How are you going to develop against that? How are you going to debug against that? So it's very difficult to manage that as a developer. Yes, there's Aspire, but that's not the panacea of all. They are difficult to develop and deploy. But they are hugely scalable, and your CTO may be like, yes, we definitely need this. So there is that swagger about that. Oh, we work on microservices. My company, oh yeah, we do microservices. And I was in that boat. I really wanted to go work for Domino's. Their head office is where I live. And I was like, they do microservices. I so want to go and do that. Thank goodness they didn't think I was good enough, that I didn't have to go into their toxic environment. But there is this whole thing that we want to do that resume-driven development, that we want to go and do these things. We want to implement them into our code bases because it's cool, and people like me come up and stand there and go, oh yes, you should totally do a modular monolith. So now you're all going, yeah, let's do that, okay? So anyway, I've digressed there on a rant. I will rant, I apologize. So let's get back on track. Why are we at this this situation? Why are we here? It's because we want to scale and meet growing demand. I mean, any website, any service, any business, you want to grow. That's how you all pay your bills. So we want to be able to do that. And what are our options? Well, with your current monolith, you could scale the entire app. You could do that horizontally by more instances, or vertically with more compute. You could go and optimize it. You could look for bottlenecks. You could go and do some refactoring, and that could be one way that you make it work for you. Or you go the way of the distributed system, so breaking that app up, and everything can be scaled independently, and all those amazing things that people tell you you can do and why you should go into distributed architecture. So if we think about comparing the two architectures, I've already covered a lot of these. So in general, things on a monolith, easy for you as the developer. You could right-click publish if you so desire. It's really easy for newcomers to come in. You just download that one repository, press play. Hey, you're running. Yay, it's awesome. You can put your breakpoints in. Everything flows through. Lovely. Harder to deploy in the way that in speed of deployment, not harder to deploy because, as I said, you could right-click publish or just drag it on to an FTP, whatever you so wish. But for deployment, because it's so big and there's so many moving parts, you may not want to deploy it hundreds of times a day, okay? I worked on a telecoms application, had millions of records. You've probably had your phone calls go through it. And I worked at that company for 18 months and did whole loads of features and everything. There was not one deployment in that whole 18 months that I was there. They upgraded, I know my friend still works there and we go for regular walks. She said they went through and upgraded everything to .NET 6 last year. They haven't deployed that yet, they're too scared. Okay, so you get into this spot with sort of this monolithic development that you can't just deploy it. If you have your microservices, they're smaller, you have more of a big picture of the whole thing. You can do your changes and deploy it then and there, quick and rapid, and that's one of the big selling points of microservices. And it's flexible and all the things that we've heard about. So it really does sound straightforward, and this is why so many companies have gone the route of microservices, because they're like, yes, this is what we need to grow. This is how we need to do it. All 5 of our developers are going to now manage microservices. It's going to be awesome. But they do come at a cost, and that is simplicity. Okay, so we need to remember that. They are very complex. You are going to need to get a lot of new skills and knowledge and new people to be able to do them. So let's think about, you've decided you do need microservices and you are 100% convinced that you do, and you have the right people and the right skills in-house to go and do it. What does that journey to distribution look like? So I quite like this chart. We have our modularization and our distribution. Our monolith is stuck down there. It's not modularized and it's not distributed. And then our microservices, highly modularized and distributed. And we want to go straight there. Yeah? Easy peasy, yeah? You're all saying, yeah, we can totally do that. No, you are going to end up with a distributed monolith. And you will end up there, I can tell you. You will end up with a distributed monolith. And that's okay, but a lot of companies and a lot of dev teams get scared when they get in that distributed monolith. They have a panic. They're like, oh my goodness, we're here, and they don't keep pushing forward, okay? You have to break a few eggs to make an omelet. The distributed monolith is the breaking of the eggs, but you have to keep going. So you might be wondering, I warned you. You might be wondering, what exactly do I mean by a distributed monolith? Why is it so horrible to end up there? So let's go and see what the problem is, okay? So what is it? we're going to have a contrived example. We've got two services, and this is my pet peeve, shared databases. The number one thing I get asked when I talk about distributed architecture is, do we really need a database per service? Do we really, Layla? And I'm like, this is my soapbox. I am going to stand on this, and I will tell you yes, because of this precise reason, okay? Here they are. They share a database. I need to do some changes to this service. I need to do a database update. I'm going to do a migration. Now we've done that, but I need to deploy today. I need to send those migrations out to my database. Hello, this guy over here. I have to go and fix him now. I have to get a database migration done there, something in there. I might not own that service. The team working on that service might be doing something else, and this is not a priority for them. So now what are we doing? Well, we're stuck with our major thing that we have to release on ours, our feature, our bug fix, our catastrophic failure. Well, no, we have coupled, and now we have to tag that other application along with our little application, that they're little services, and this one has to come along. It's great fun playing with generative AI to do these sort of concepts. So our services are now tightly coupled and cannot be updated and deployed independently, which is the big selling point of microservices, or one of the big selling points. So our developer life just got hard. All of the complexity of a distributed system, because we've got all these supporting services, all the hardships I've ranted about already, and none of the benefits of independent, discrete services, okay? And none of the ease of monolithic development and debugging. So this is a really crappy place to be. You do not want to be there, okay? So one thing that we need to start bearing in mind as we move on this journey is the golden rule of loose coupling and high cohesion. I'll come back to that more, but I just want to try and get that seated in your head already, that this is really important as we move on this journey, the more pleasant journey, okay? So let's come to our chart again, and now we have our fourth option. We have our not distributed but modularized modular monolith. Now we can start moving towards the modular monolith, and we can stay there, or we can hop out into our microservices. Because we're already modularized, it will be so much more simple to go to our distributed architecture. So this is a much better path than the red corner, okay? So now let's come back to what we need to scale and meet growing demand. We've now got a third option, the best of both worlds. Yay! It's that, magic bullet. But it has a lot of the problems of both, okay? So I just want to put that little fly in the ointment there. Lots of the same problems from both of them. Okay, so what is a modular monolith? So this is where we have everything modularized in a single code base, a single executable, okay? Now, in theory, you could swap out a module for another one. It's always that story like having the repository pattern. Are you ever going to swap out your repository? I have spoken to people who have, and there's always that option. You could swap out a module, okay? You might do. If you need to go into that modularity and that is important, then this is a good way to go. And I'd like to introduce you to the Kit Kat pattern. Okay, I have quite a few of my own patterns. I'm big on patterns. But before we can proceed, I have a question for you. And don't be shy. I need you to actually answer me, okay? Truthfully, hands up. Who eats their Kit Kat like that? Good. Put your hands up higher. That's it. Okay. Once. There's quite a few of you. Monsters. You're monsters. Absolute monsters. That's all I can say, okay? if you eat it the proper way, breaking it off, nibbling all the chocolate around the end, taking the layers off, like, you know, dissecting it completely, that's the proper way. Disgusting, I know, but, you know, I'll let you off for breaking a finger and nibbling it, it's fine. I want you to liken your monolith to a Kit Kat bar. Okay, it's an entire Kit Kat bar, and a finger represents an individual module. If you think about it, a Kit Kat is a biscuit covered in chocolate, or wafer covered in chocolate. A finger is a wafer covered in chocolate. So now you see, it's all nice and modular. And we can take that finger off. It's a self-contained chocolate bar, just like a module in your application. And if I had this boring milk chocolate Kit Kat and you had a delicious matcha Kit Kat, that's my favorite, hard to get, I could swap one of my fingers for your matcha finger, and I would still have a whole Kit Kat bar. I would just have a different module. Okay, so that's why I feel like it clicks in my head. My head may be a weird jumbled mess, but hopefully it might go and click in yours. But you're now going, how does all this work in my application? So let's go in and delve into that a little bit more. This is your plain old monolith, okay? I have an N-tier architecture here. We have an API, we have a logic layer, and we have a data access layer. Now, you may go, well, I have N-tier, I have a big ball of mud, clean, onion, hexagon, carrot. I really don't care what architecture you're using, okay? I'm going to talk about N-tier because most people will understand that. You can take these principles. If you're using a different architecture, you will be able to apply these principles to your spangly fruit flavored architecture, whatever it is, okay? So you can lay this on whatever you have. So we're going to slice our architecture up vertically in this case, and now we have lots of mini API, logic, and data access layers. We've got them all divided up. Now, some of you may be thinking, well, is this vertical slice architecture? There are similarities, but they are not the same. Vertical slice architecture is where you take a feature and you stick everything to do with that feature in a folder. Okay, all of the things, it's all encapsulated in a folder. Now, you can apply that principle to your monolith, your modular monolith, your distributed architecture. You can apply it anywhere. So similar idea, but definitely not the same. All right, so how do we go about decomposing our application? Right, so remember, the golden rule, loose coupling and high cohesion. This is what you need to keep at the forefront of your mind as you go through and start to decompose your app. Now, elements within a module have high cohesion and are tightly related to each other. And this enables us to keep that code loosely coupled, where we can write code within one module without impacting other modules. So let's say we have a bucket of Duplo and we have a bucket of Lego. We don't want to jumble them up together because they don't work very well together from memory. Anyway, I don't think you can use Duplo with Lego. No? Oh my God. Damn it. But Duplo is so big. Anyway, they're kind of, you can work them together, but you shouldn't mix them, okay? We're going to go with that. Don't mix your Duplos and your Lego, okay? Thank you, Dylan. So we're going to go with that, and you're going to forget that you can use them together, or if you have to, you can use them together. So with our cohesion versus coupling, cohesion is the degree in which elements in a module belong together. All of the red bricks are in the thing together. All shades of red are in one bucket together. All shades of blue are in a bucket together. So they're similar, they're all together. You don't have all the reds with a blue shoved in there because it doesn't belong. Okay, it doesn't belong. Now, a module with high cohesion contains elements that are tightly related to each other. So you might have everything to do with inventory in one module. You might have everything to do with customers in another module. You're not going to have inventory and customers spread across two modules because now you're coupling them together. So modules with loose coupling work mostly independent of each other. So that's where we want to go. All right, so the best way to go about it is incrementally, in the largest chunks possible. Now, if DDD is your thing, you can go that way and start, doing it that way, or you can do it like this. It really is down to how your team works and the things that you do within your team. But remember, simplicity is your friend. We definitely need to have the biggest chunks. If you get too granular too quickly, you might find that you're coupling your modules. It's much easier if you get the biggest chunks possible into it and then look at that critically and go, actually, we need to break that down further, because you can still break it down further. So as required. So nice big chunks, and that will make your life a lot easier. So what about the pesky database? I'm not really into databases. I don't like databases. When I started out as a developer, the fear of God was put into me about databases and updating them and dropping the live database. My director did that on Boxing Day, and he was fiddling around, didn't realize he was connected in his SQL Server Management Studio to the live, dropped it. We only had a week of backups. He did it on Boxing Day. We got back like 8 days later, and everyone's pinging me because I was the lead on that project, and they're like, Layla, we can't get into the app. This was one that ran our entire team and had like 8 years of data in it. And I'm going into our Azure account. I'm like, and I could see when it was dropped, and I was like, well, I wasn't working on it on Boxing Day. I was, drinking fizz and eating mince pies. But so I have a lot of fear and respect for databases. So we have two options. We can go code first, or we can go database first. So let's think about code first. As a developer, we probably want to delve into the code and slice that up, do all that whizzy stuff first. The risk here is that if you go into your database and you can't tease apart the stuff that you need to match your code, you're going to have to put your code back into your module and then go data first. I would recommend, if you have a DBA, go and talk to them, because they're very protective of their data. Go and say, I'm thinking of doing this, and then duck and cover, okay? But go and have a chat with them. Do this holistically as a team and think, is the data going to be a pain in the derriere to get out? Yes, we'll do that first. If it's like, no, it's pretty straightforward, we'll take the code out. That's where our complexity is. So base, doing the hard stuff first. Eat the frog first. But you're all going to be like, rolling your eyes at me. What if you're here? You've taken your code out and you've got your shared database. What if you stayed here? Well, we are in a modular monolith. Do we actually need to decompose the database fully? Okay. Perhaps not, okay, because we're trying to be pragmatic, not dogmatic. There may be other stresses on you as a developer, and you're like, we need to get this module out, but we're still in the same code base. We'll keep that data there. But no, if you don't take your data out into its own schema, its own system, whatever, you are accruing technical debt. And technical debt is okay if you know about it and it doesn't come and bite you later on when you need to do something in a hurry. So if you don't want to decompose your data fully at the time you take your code out, it's okay as long as you know about it. So I will let you have that, okay, for all those people who don't want separate databases. So how is this Distribu-ready? Okay, because that's the title of the talk. Well, remember this down here, when you eat a Kit Kat the proper way, a finger can be broken off and is in itself a self-contained chocolate bar, just like a module in your application. So DHH came up with the Citadel pattern. That doesn't make any sense to me. I don't get it. So I don't agree with that naming. We have the satellite pattern. Much, much betterer. And that is a word, my mum says so. So we have our satellites. I have been talking about satellites and monoliths for years and years and years. I think it's where we all should be. So what we have is a central, could be modular monolith, with self-contained modules that can be broken off and become satellites. So here is your monolith, here is your satellite, okay? Satellites are distributed, they can be converted into standalone apps, they can be containerized, they can be serverless functions. So, you know, like let's say you put it in an Azure function, you can have that doing nothing at all until you need it. So for example, you have it as a notification service or an email service, and you're sending out emails once a day or once a week. You can spool up that email service, queue up all of your emails using a whole system there, like through like functions. It goes off and does that stuff. It takes all that load away from your monolith and is done, and then gets scaled back down. But the rest of your monolith is a monolith. So you can start taking out these things and go distributed incrementally, okay? So it's a much better way to go. That leads us to an important question, and that is how we go about and do that. How do we ensure the modules remain completely independent? That's a big issue. How will our modules communicate? And how do we enforce the architecture? So we have Taki-Takas. That's a project I've been working on for a very long time. I do have a new project that I'm working on, but Taki-Takas was the one that I've been working on the longest. And I made that was originally distributed, and now it's a modular architecture. So this is what it looks like. We have our client. Like that can be, you can ignore that because you might be a web API. You might just be an API, not even have a client. But we have our web API layer, which is our executable, and then we have our logic, which has all of our modules within it. So things to note, that client app could be on a CDN somewhere. We don't care about it. It's front-end crap. So our web API layer, that extends the API endpoints in our modules, okay? And those modules still keep all of their endpoints and their logic encapsulated within them. And then our logic layer, our modules will abide by strict intercommunication rules set out in a contract, okay? So we do need to be quite strict on our rules and how we go about things to keep everything hunky-dory. Now, projects within the monolith, we have our web API, and then each one of these is a project, a CS proj, okay? So we have our menu tests, menu contracts, and all of that. And that's because in .NET, we need to modularize using project files. That's kind of the only way we have about going to it. So that's why we start to do that. They're class libraries, so you can just I know some people who make them executables, but don't run them because then they say, well, it's easier, I can just carve it off and make it its own executable. I prefer to have them class libraries, okay? So, and this is what the web API CS project looks like. It is the only project that is allowed to reference any of the modules directly, okay? That is the rule. So it will bring in all of those modules. Now, in an individual module, they can only reference the contracts. They can't directly reference another module. Now, I will just put in a caveat. These are my rules. You can take these rules, you can extend them, you can come up with your own rules. I'm just going to give you an idea of how you need to define rules within your application. So how are we going to communicate? Well, let's start with the easier bit, the external communication. We've got our web client, and that's going to do a REST call. It comes through to our web API, and then the web API is able to access the menu's endpoints. It's in the module, it runs those endpoints, does all of its stuff, and returns whatever the request was. You can even have your web API call two different modules and then collate that, or you might have another little layer in there that does that, but you can start to combine data from different modules by doing these calls, okay? But the important thing here is that those two modules are not speaking to each other, okay? So endpoints in a module, I'm showing it here with minimal APIs because I think they're really lightweight, they're really easy to understand, they're really readable, and they really fit well with this. So this is an extension method that I've written, and this one extends the web application app. And in here, we're going to define all of our endpoints. And then you'll notice that that was internal. That's really key. That is internal only. So we then need something for the web API, which is referencing our orders project, to be able to come and find those endpoints. So then we have this public extension method, again, extending web application, and this is going to be our add order endpoint. So that is going to add all of our endpoints to our web application inside the web API. We also need to get all of our dependencies into our IOC container. So in this case, I've extended iService collection, but you could extend Web Application Builder if you prefer. It's a preference thing, and you may do it one way in one and another way in another. So here we can start to add our context, our services, whatever you have that is in your module that needs to be instantiated and managed by the IOC container in the web API. So we do that, and then in our web API we can call them, because remember we've got references to these modules. So here we can have all of our services added, so add orders, add payments, add menu, and then we can bring in all of our endpoints down the bottom. So we've got our app.add-order endpoints, app.add-payment endpoints. So we've got that. It's very readable. You can go through and see, okay, this is everything I've got in my application. I've got all my modules in there. So that's pretty straightforward. But what about inter-module communication? Now, some people have come up to me and said, oh, we do direct calls. Okay, that's kind of fine. You can make a public-facing interface for modules to talk to each other, but you might end up like this, okay? And that's not aesthetically pleasing to me. I'm sorry, it's not. But if that's your jam, then fine. But if I wanted to take this little dude here out into a satellite, I've got to sort out all those little connections to him, and I don't want to do that. I just don't. So I prefer to do something other than direct calls, and that is to use a mediator. And that's not mediator with no O. This is just a mediator using a traditional mediator pattern. This is what I mean. You can write these things yourself. You don't need all of that. Mediator uses CQRS or whatever, CQS, some version of command query response, whatever it is, buzzwords. But a mediator is just that. It mediates between two services. And you can write this yourself. And it's complex, so I'm trying to give you a taste of what that looks like. We have a service which implements an iMediator, and then we have listeners. And all of your things that need to receive messages will listen, and everything. So all of your inbound messages get sent to a listener based on a key. And this is the way I implement it, okay? I need to have a key, and you'll see why in a minute. And then this mediator service is going to notify all those listeners by key, okay? So you have something listening to it, and that's listening for anything by a key, and then you have a central service that is taking the messages and then sending it out to all those services, okay? So for example, I have an order paid update listener, I have an order details request listener, and a new orders listener. And they are all registered with the module mediator, and that's done on key. And that looks kind of like this. So I add all of my listeners to my IOC container, and then I go and get my service provider, and then I get all of those implementations of iListener, and then I iterate over those and add them to a dictionary based on their key. So when I come to send a message, to notify, I say, hey, can I have all of the listeners that are registered against this key? All right, loop over and send this message to them, okay? So that's all the mediator does. And the second way we can do that is to use a message broker. And just quickly, a message broker, I'm sure many of you are familiar with it, but it basically, we have a producer, it creates a message which gets shoved onto a queue, and then a consumer can come along and take that message off when it's ready, okay? It's nice like that. It handles lots of volume nicely for you. So we have our order here, we'll put something on the message broker queue, and the kitchen will take it when it's ready. And that looks like this. And we've got that decreased culling, we've got that, and hey, doesn't that look kind of like that? Yeah? And like that. So really similar. See, reasons. If the mediator is implemented mindfully, that transition to using something like a message bus, a messaging service, is trivial as any of those things can do. Trivial is not a word I bandy around lightly, but compared to the alternative, if you just willy-nilly'd it all, it's trivial. Okay, so a system like this is sometimes referred to as event-driven or message-driven, and things to note, okay, is that as the web API layer is the only executable, all producers and consumers need to be registered in the web API. So it's a bit counterintuitive because you're used to having a service A sending a message here to service B. All of those need to be in your web API because you're messaging yourself, but you're not. So it's a little bit to get your head around. And I'm just mindful of time. So we have types of messaging, and we have thin messages, which are kind of like a little event. It's like, hey, this order ID has been paid. It's very little bit of data. It's really an update. Now, a fat message is like, hey, this is order ID XYZ, and they want 6 tacos, 8 burritos, and 5 guacamoles, okay? So it's a fat message, it's got lots of data. Now, how does that work in our system, and why do you need to know about it? So if we have an order placed, we've got all of our modules, okay? How are we going to update them in their respective databases? So we create an order because the order module owns the order data, okay? We create that, but then the payment is like, okay, I've got this order and I need to take payment for £30. So it goes and does that, and then it needs to tell people, it doesn't care who, hey, this is paid. So it goes and makes a message that is this order ID with key orders.update.paid, okay? So I make my keys dot separated like that because I use RabbitMQ, and that just goes straight onto a topic exchange, as you can see here. So we have that. Now the order goes, oh, okay, great. That order ID, I'll update it, it's paid. The kitchen is also listening to that. It goes, okay, order ID, it's paid, what am I making? So it then has to say to the order module, hey, what is the order on this ID? So it sends out a request and goes, hey, can I have the order details? And then the order creates the big fat message with all of the details and sends that to the kitchen. So that is important because they can get chatty, you can be sending too much data around, not everybody needs to know all of this. So you need to know which needs like a thin message and which needs a fat message. Don't just send all the data around because they may not even have all the data, the ones sending the notification. So you need to be aware of these different patterns. But oh my goodness, have we drastically increased the complexity of this system? It is, yeah, it's not great, is it? We now have to consider error handling and implementation details of a message-based architecture. That is not simple. All right, so our modules are loosely coupled and easier to convert to satellite. So that's our trade-off. All right, do you need that? But we need to now think about preventing the inevitable. How do we stop things turning into a big ball of mud? It could be so easy All right. Now we have a couple of different things to enforce architecture: code review, compile time, automated tests, and a style guide. Okay, code review. Let's include pair programming in that. Benefits: sharing of knowledge. It's great to pair program. You can really move quickly when you pair program. Encourages open discussion and challenging the status quo. However, I will say that using your valuable pair programming time to look at enforcing architecture is not the best use of time, okay? Also, the person who's your pair programming with also needs to know the architecture, and they might not, and that should be used for innovating, not checking if you've done it right, okay? So I don't think it's the best use of that time. Compile time. So this is through encapsulation. This is why we have all of those projects. That's why I drew your attention to internal. We adopt this private by default and separate each module into a distinct project or assembly and use the internal access. And now for your tests, or if you really need something exposed, you can put internals visible too in your CS proj to open up the internals to other projects, okay? So you can get around that if you need to. So you remember this is our contracts here, and this is how we encapsulate our code. We have these contracts, which are the missing link between our modules. So for a more understandable thing, we have our order module, and it's going to make something in an order DTO, data transfer object. Shoves that onto the message broker or through the mediator. Our kitchen module can pick that up. It understands it because we have the contract. It can decode that and do what it needs to with it. Okay, so we have this shared knowledge between them. So the benefits is it's immediate feedback. Okay. Now drawbacks, people have said, oh, well, you know, you can use reflection or the unsafe accessor. If you are doing that, you know what you're doing and you are purposefully circumnavigating the rules, and shame on you if it all goes wrong and you screw it up, okay? You knew what you were doing when you did that. This is a way of saying, hey, you shouldn't do that. You shouldn't have access to that. If you then ignore that and go off and do something, that's on you, okay? But this is a way of helping most of the developers not do the wrong thing. It's undocumented as well. Automated tests, so let's go static code analysis tools and architecture tests. Benefits of the analysis tools is they're automated, they're self-documenting, they do reports, they integrate with your IDE, CI, CD. They've got this weird language that I really struggle to understand, and you can set all these things up. But they do all of this. I'm not going to read it. Quick look, pass it, photographic memory, look at it later. But yeah, they're pretty cool. Now, architecture tests. These are automated, they are self-documenting, fast feedback, and all the benefit of tests, but for your architecture. So I definitely recommend implementing architecture tests. Drawbacks, they take time and discipline to implement, and you need good code coverage, or else what's the point? This is an architecture test here. There's two main libraries. I do have a YouTube video covering them both and why I prefer one over the other, so go and watch that. But they're very readable. So classes that reside in assembly kitchen module should not depend on any types that do not reside in assembly order module. Check the architecture, and you register the architecture as all of your modules. So they use this lovely Fluent API here. They're readable, and they help define the rules there, okay? So have a look at those. And finally, a style guide. It's documented, and it's a resource for everyone to go look at. This is Google's style guide, so you can adopt that as that. It's a lot of stuff that you already know, but you can start to put your module styles and implementations in there. Wow, God, need to breathe. So to summarize the modular monolith, use it where the modularity is important, okay? Because you are adding a lot of complexity here. If you do not need the modularity, don't do it, okay? Simple as. Only do it if you need to do it. Key things to remember: be pragmatic, not dogmatic. That's like my mantra. Be aware of the technical debt, and high cohesion, loose coupling. And now for the question you'll all want to ask: can I use .NET Aspire in a modular monolith? Yes, you can. And that's it. There you go. Yes, you can. My YouTube, I have videos on these things, quite a few of the different things I've spoken about today, particularly on the architecture tests. I rant a lot about the beauties of modular monoliths on this episode of .NET Rocks. It's 1856. You can just Google me and .NET Rocks, and there's a few of them, but go for this one. This is the one where I rant the most. And if you want to learn more, I've got a 2-day workshop at NDC London in January where we build a modular monolith using Aspire. Okay, so there is that. Or you could go to Dylan's on how to come and stand up here and do this. So you have a choice. And that's it. Thank you. That's me. Done. Woohoo!